In this video, I'm going to show you how I organize the wires coming off of the stepper motors and how to install the limit switches. All right, let's go. For the next step, I wanted to organize the wires coming off of the stepper motors. There were 8 wires coming off of each motor, so I mounted these terminal blocks and connected the wires. The wires will be connected in pairs. So on these particular motors, the red and black are connected together, and then it's the red and blue that are connected together, and then it's the black and yellow, and then the brown and white are connected together, and then the green and orange wires are connected together. And this will allow the motors to be wired in what's called a bipolar parallel mode. And yeah, so out of these connector blocks, I will run other cables. I have a shielded 4-conductor cable that I'll run out of this, and that way you want the shielding on there to prevent any noise and any signal noise that would interfere with the signals going over the wires. So and you don't want those the high currents going through those wires to interfere with other signals. So shielding it is a good idea. But I left the wires as is coming off of the stepper motors and used these terminal blocks so that I don't have to permanently mount the wires in any in any particular configuration. So to mount the limit switches, I have some switches here that I'm going to use. So they have a little roller on this arm, and when the arm is pressed, then the switch is activated. So I can mount these, like maybe for the y-axis, I can mount one back here, but if I do, then I'm going to need to put something back here on this board. So if I make a couple of these, the thickness there is enough that would bring it out past the edge here and is able to catch that arm and activate the switch. The other thing that I might do, because I don't really want to build this out with so thick of a wood there, is I might cut a notch in the back of this gantry side so that the switch can mount not here on this edge, but further in, like this. Now I don't want to mount it all the way in so that it activates. Let's move this out of the way. I don't want it to activate on this edge right here. I do want to have some type of board here just so that the switch can be adjusted as to when it activates. So by having a board with some screws here that are in either a slot or an oversized hole so that the board can be moved back and forth a bit, I think that'll be important to fine-tune when the switch activates. And by moving the switch in a little bit, then I don't need to build this out with a real thick piece of wood. I can just do one piece of wood here and try to get it adjusted. So that's what I think I'm going to do, is I'm going to mount one of the switches on this side, cut into the gantry side a little bit, so it'll be back here. And then there will be another switch over here on this side for either end of the y-axis. For the x-axis, I'm thinking I will mount the switches down here somewhere. Haven't really decided yet exactly how I'm going to do this. Maybe I can mount it this way to catch the edge of this right here. I don't really have a lot of room to make another board to stick out, so for these I might make the switch itself adjustable a bit as to where it gets mounted. So I could do something like that for the x-axis, and for the z-axis, well, that'll be a completely different story. I'll get to that one after I finish the x and y-axis limit switches. Alright, I have the y-axis limit switches installed with their adjustable plates that will trigger the switches. And the way that you want to do this is I brought this all the way over to the to the actual limit and then backed it up a little bit and then adjusted the block to trigger that switch at that location that's slightly off of the limit. You don't want the limit switches to trigger at the exact actual limit of movement. So you can see here, there's where it clicked, but it can actually move a bit more. So it actually triggers there, but it can move a bit more. So that allows the motors time to slow down. What'll happen when it's trying to find the limit is it will come in at speed. When it hits the switch, it'll start stopping. But it may not stop right away, so it might go past it a little bit, and then what it should do is it will back up and then come in slowly until it just hits the switch, and that's where it will have the actual stop at the limit. And then I did the same thing for the other side. So both switches are mounted so that they will trigger, and I left a little bit of room down below the switch to plug in the wire connectors. For the X-axis limit switches, here's the design that I came up with. This is the gantry at its maximum actual movement, and if we move it back a little bit, that's kind of where I want it to stop. So by putting a piece of plywood right here, and I'll attach this plywood in with some screws, then we should be able to mount a limit switch right about here so that it clicks right there. Now it won't be as adjustable as the Y-axis, but I think this will work out pretty good anyway. Here's the X-axis limit switch, at least one end. The other end looks identical to this, and if we push the gantry back a bit, we can see that it will, right about there, it will trigger the switch. So there's a bit of a gap right here that I'm looking for, so it doesn't go all the way to its actual limit, and the switch should stop it before it gets there. For the Z-axis, I was able to mount one upper limit switch right here on the side of this board, and that will hit on the top surface of the board right below it. But for the bottom limit switch, the limit is a little bit higher, and the switch would not have been able to screw into this board. So what I'm going to do is I'm going to glue on, maybe screw on, I'm not sure yet, a little spacer board here, and that will allow this switch to be able to mount like this. So it'll have to mount, it needs to mount higher than this board, and the reason for that is this whole Z-axis assembly doesn't come down as far as it goes up. And that's because we don't just have a collar down here, but we also have some bolts sticking out here for the backlash nut. So the amount that this goes down is a little bit higher than the gap at the top. So yeah, so I'm going to put that spacer board on there, and then I should be able to screw on the last limit switch. Here's what I came up with for the limit switches for the Z-axis. This is the top switch, and it might look a little strange, but sitting at diagonal like that actually lined up the screw holes that I needed to drill more in the center of the MDF wood. And as the Z-axis raises up, this top edge of the board here will hit this limit switch and will trigger the top. And for down at the bottom, the distance between the board here and this was greater, so I needed to put this spacer board on that I glued in place, and now the switch here will trigger at the bottom of the the travel. So yeah, so that's it. So that's the Z-axis. And going over again, we have the Y-axis over here and here, and the X-axis here on this block of wood, and right here on this end. So yeah, all 6 limit switches are in place. So I'm going to, I still need to wire it up and everything, but I think I'm going to put the wiring in another video. And I think this one will be all about the limit switches. So I'm going to get this video posted. All right, bye.